Hi everyone, this is Vijaya Bhaskara Reddy, working as assistant professor in the Department of CSE, VNR VJEC, Hyderabad. Today I would like to discuss about one very important concept, exception handling in Java programming. Okay, before going to discuss about it, exception handling, let us see what are the various kinds of errors we can have, okay, while doing programming. So basically, coming to errors part, okay, we have three kinds of errors. So first one is syntactical errors, and second one is logical errors, and we can encounter sometimes during program execution, okay, we can call them as runtime errors. So what exactly mean by an error? So error means it's a mistake done by programmer. So generally while writing some code, we do many mistakes, right? So you can treat that as an error. So that might be either syntax error, or it might be logical error, or sometimes we can say that it would result to you a runtime error also. So what is syntax error? So whenever if you are violating any language rule, right? So for suppose if you forget to keep any semicolon in variable declaration at the end of the statement, generally we keep semicolon, right? If you forget it, it comes under language violation, right? So it leads to syntax error. Who takes care about this syntax error? So compiler. So during compilation itself, you will get information about that particular error. Okay. And coming back to logical errors. What do you mean by logical error? A logical error generally occurs through our program, whatever the code you are writing here, right? So in your code, you have written some logic for getting some desired result, but unfortunately, because of your wrong logic, right? So you might get another result. So just that is the issue with your logic part. So you can fix it, right, later. This is what logical error. So especially logical errors means so you are writing logic for getting some result, but you are not getting the exact result what you are expecting, right? Instead of that, you are getting some other result. So just you fix your logic. That's it, right? That is what logical error. Okay. Then what about runtime error? This is what our concept now. During program execution, generally we encounter many errors, right? So we call them as exception. So runtime errors are called exceptions, right? So what is runtime error? During program execution, whatever the error you are getting, okay, during program execution, who executes our program? JVM, we know it, right? So JVM will take care about this exception handling mechanism. So, and we know that JVM is part of our Java runtime system, right? So if we see the actual definition, or the way how we describe our exception, an exception is an abnormal condition. So abnormal condition that arises in our code, whatever we are writing, and it is going to be executed, and during program execution, that is at runtime, JVM is going to identify that and it throws that exception. Simply, in other words, so this is what simply we can define what is an exception. It's a runtime error. So, and we know that in Java, directly or indirectly, everything is what? It is an object. Everything is an object. Okay, except we have primitive types. Okay, for primitive types also we can represent them as an object also. Okay, no problem with that. So now directly, indirectly, everything in Java is an object. In the same way here, exceptions also what? Objects only. So we'll come back to that point later. So what is exception? A Java exception is an object that describes an exceptional condition. So whenever some exceptional condition, some abnormal condition occurred, okay, so that exception object describes that, okay, during program execution, whatever we are getting. So that error is what? Exception. Let us go to the next one. For example, see, if you see this code, okay, here I have class, we know that, and we can have some starting method, program starting, our program execution starts from main method, we know that. And here I have declared 3 variables and one variable value 45 and second variable value, what is that? B value 0. Okay, syntactically everything is correct here. And just have a glance about this next followed by statement, C equal to A by B. This is also a valid statement. Syntactically everything is correct, right? But see, this is assignment operator, C equal to A by B. So we know that first RHS is going to be evaluated, the result is going to be assigned to C. So what is the expression we have on RHS side? A by B. So what is the value of A by B? Sorry, here it is not X, this is A. What is the value of A? It's a 45 divided by 0. So what is the value of something divided by 0? So we cannot infinity, we cannot represent it. In the same way, JVM also cannot represent that value. So it cannot handle that situation. So during this statement execution, JVM immediately what happens? JVM will do one thing. Okay. It creates an object like this. It is an object. Okay. What is that object? Some arithmetic exception object, and throws it to the one person. Who is this? This is what? Exception handler. Exception handler. See, in our code, I have not provided any exception handler, but exception handler will be there somewhere, right? So he will take care about that exception object. Where can I find this default? Where can I find this handler? This handler is not providing by you. So our Java runtime system by default provides this handler. We are calling this as default handler. Default handler. So whenever an exception is raised, immediately JVM creates an object and throws that object to corresponding handler. Right now I don't have any handler. By default, Java runtime system provides this default handler. So the default handler will process this exception object. Now, after receiving this exception object by the default handler, what he does? He processes it. He processes it, and finally he displays one string information. String information. We'll see how we get that information and all. So regarding the previous slide, I have some questions here. Who raises the exception? So Java compiler doesn't raise, right? But who raises the exception? Always during execution only we are getting errors, right? Exceptions, right? So JVM will come into the picture. He raises that. JVM raises the exception. Did you provide any handler in the above code? No, I have not provided. That's why we are depending on Java runtime system handler, right? Default handler. So who provides that? Our Java runtime system. Who is handling that arithmetic exception? In the previous case, I have not provided any exception handler, right? So then default handler is going to handle it. So default handler, after receiving that exception object, he processes it and displays some information in string format. How the description would be like this. If you observe this, this is what the description provided by the default handler. The first part is what? This is what type of exception. It is denoting type of exception. And after that, we have here some description. He provides by default, right? And this is what? Stack trace. From which point of line, from where we are getting that exception. Clearly, he explains. So these three parts are very important for a programmer to do a debugging process, right? So all this combinedly, this is what type of data? It's a string type data. Okay. So this is very important point. Any exception that is not caught by your program, just now we have seen, I have not provided any exception handler. So in that case, who will handle that exception? Default handler provided by the Java runtime system. Exceptions can be generated by either two people. One is either Java runtime system or by the programmer. So Java runtime system, whenever if you violate language rules or if you are writing some code which it cannot handle, in that case Java runtime system will identify that scenarios and accordingly he raises exceptions, right? But in some cases, in built-in Java runtime system providing exceptions are not feasible to us to define our scenarios, right? In that case, we can go with our own exception objects, right? So you can define your own exception objects, you can describe that scenarios, right? Now coming to Java exception handling mechanism. So why should we go with Java exception handling mechanism? First of all, what is the problem when you encounter an exception in Java, right? So for example, here I have some code, right? So my code is causing an exception. What happens after? Let us see here. I have 5 lines of code. After execution of line 1, I'll go with line 2. After that, at line number 3, we are expecting some exception, right? So when it encounters an exception case, some abnormal case, what happens? Immediately that program execution is going to be terminated. Entire application is going to be terminated. This is not desiring solution. Okay, what an end user expects generally, right? So suddenly, if your application is terminated, okay, end user definitely he doesn't understand what is happening internally in our machine, right? For example, right? Now, when we encounter an exception, okay, what is happening? Our application is going to be terminated completely, right? So now, using Java exception handling mechanism, instead of terminating the entire application when I encounter an exception, instead of terminating entire application, I am going to terminate only some part some part of line, some part of code from which we are getting that exception. I am not terminating entire program. Simply the code which is causing that exception, just I am terminating that code part only. I am not terminating the entire program, right? So we can handle this scenario, we can handle this situation using Java exception handling mechanism. So in Java exception handling mechanism, we can handle exceptions using these 5 keywords. So here I have listed out: try, catch, throw, throws, finally. So we'll discuss one by one in detail in further sessions. But right now, so what these 3 are important: try, catch, and finally. These 3 are important. So to handle exceptions, basically we go with these 3. So what kind of thing we write in try block? If you observe this general form of exception handling block, so here I have try block. In try block, we write the code. So which causes what? An exception. Whatever the code you are writing here, that might cause, right? There is no guarantee. Definitely we get exception from this code, right? It might cause an exception. So I am calling it as what? Some doubtful code. So some doubtful code I am going to keep inside try block. So whenever that doubtful code raises an exception, that is going to be held by the corresponding catch block. So he is going to catch it. He is going to handle that exception. So generally we call catch block as what? Handler. Handler. So finally we keep what? Some doubtful code inside try block. Okay. Followed by we can provide our own handler. If you want to provide your own handler, which block you have to define? Catch block. And a try block can be followed by multiple catch blocks. No issue with that. And coming to finally. Finally. So what kind of statements we write in finally? So block of code definitely which must be executed before try block ends. So whether your try block is generating an exception or not, don't worry about it, right? So definitely executable statements you must keep inside what? Finally block. For suppose if this try block is not raising any exception, then whatever the code you mentioned inside finally block, definitely it is going to be executed. For suppose if the try block is raising an exception, in that case also the statements whatever we have listed out definitely are going to be executed. Okay. See here, I am going to handle some exception using Java exception handling mechanism providing keywords. What are the keywords? Just now we have seen try, catch, and finally. Here in our application, I am using try and catch. If you observe this try, this is what the doubtful code I am keeping inside try block. So here, what is the value of A? 45, B value 0, and here I am computing this expression. So when JVM is evaluating this statement, so what happens? Syntactically everything is correct. Simply here I am dividing 45 divided by 0. Syntactically I am dividing one number with another number. Syntactically correct. So we never get any error during compilation. But during execution, at the time of evaluation, JVM cannot handle the situation 45 divided by 0. Immediately what happens? Immediately JVM creates an exception object and it throws to the handler. Are you providing handler in this code? Yes. I am providing my catch block. So this object is going to be received by this handler. He process it. So the processing task we write here inside catch block. Processing task. So whenever you encounter an exception, whenever you receive an exception object by the catch block, whatever you want to do, that you can write inside catch block. Okay, so this is what the doubtful code, and this guy catch block is what our handler regarding that arithmetic exception. See, this is how we are getting the description after at the time of execution. We are getting description like this, because this statement system.out.println of AE, so it gives you this description. And we know that a try block can be followed by multiple catch clauses, right? So why should we deal with multiple catch clauses, right? See, we are writing some try block, right? We are writing some code. This code can generate. Can I go with only single statement inside try block? No. Generally, we keep multiple lines of statements, right? So whenever if one statement is causing one kind of exception, for suppose arithmetic exception, then we have to provide corresponding handler. No, for suppose if one statement is generating one other kind of exception, for example, array index out of bounds exception, then we have to provide corresponding handler. So to deal with a specific type of exception, we have to provide corresponding handler. So that's why a try block can be followed by multiple catch blocks. Okay, here I have one example. Let us see that, right? So here I am starting from main method. So here I have created one scanner object to read the data dynamically from the user, and here I have declared some variables, a value same 45, b and c. Here I am reading the value of b dynamically from the user. See, when I enter the value of b as 5, when I enter the value of b as 5, what is the value of b? 5. Then tell me what is the expression, what is the expression result? C equal to what? 45 by 5. Then what is the value of C? 9. So here we don't get any error. We don't get any exception. So valid statement. So I'm not dividing that 45 with 0, with some 5, right? So it is giving you 9, right? So everything is valid. But see, 1, 2, 3, 4, 5, 6, 7. Let us go with 7th statement. So at 7th statement, so what do we have? Simply we are creating an array here with 4 elements, and if you see this 8th statement, x of 50 is equal to 99. So is it possible to access element at index 50? No. Why? Because this array x last index is what? 3. We don't have any element at the specified index position 50. So what happens? So in this case, when the value of b is 5, then what happens? It executes all the statements. Now when it comes to x of 50 equal to 99, immediately JVM creates what? An exception object. What is this object? Array index out of bounds. Array index out of bounds exception. So now it throws to the corresponding handler. Have you provided that corresponding handler? Yes, we have 2 handlers here. Who is matching with that exception? So first it inspects what? First catch block. No, it is not matching with that array index out of bounds exception. So next what? It navigates to the next catch block. Yes, the corresponding handler is there. It can handle that exception object, and he is processing like using simply system.out.println statement. Okay. Now here we are generating array index out of bounds exception, and we are providing corresponding exception handler. Now, for example, if the value of b equal to 0, then what happens? At this line only we get exception. Now what happens? Immediately JVM creates arithmetic exception object and throws to the corresponding handler. If you observe, whenever we encounter an exception, the followed by statements are not going to be executed. See, when the value of b equal to 0, we come out from the statement only. That means we are not terminating entire applications. Simply we are terminating what? Try block only. We are coming out only from the try block, not from the entire application. Right. So arithmetic exception, the corresponding handler is there. He processes that exception object. That is how we can deal with exceptions, right? Try with multiple catch clauses. So this is how we can expect the outcome. So when the value of b equal to 0, we are getting what? Arithmetic exception here. And when the value of b equal to 5, then so that statement is not causing any error. That's why we are getting what? Value 9. And which statement is causing that array index out of bounds exception? So here x of 50 is equal to 99. That statement is causing that array index out of bounds exception. And if you observe, after colon, we have 50 also. That is what? The description about that exception. Because of trying to access that 50th index, right? So which is not there actually, right? So we are getting that exception. Everything is providing by what? Corresponding handler. And if you observe, so these are very important points. If you observe this scenario, from try block at a time, how many exceptions are going to be thrown? Only one exception. Always only one exception is going to be raised from the try block. And one more point, always only one catch block at a time is going to be executed. Okay, even though if you mention multiple catch blocks, right? So the corresponding handler only is going to process that raised exception object, right? These two are very important. At a time, only one exception is going to be raised from try block, and only one catch block is going to be active during handling that exception. So this is what the basic information regarding exception handling in Java. Just what we have seen so far. So what are the keywords? Try, catch, finally, and in try block, okay, we keep doubtful code. And in catch block, we write the code to handle corresponding exception scenario. And in finally, whether your code is raising an exception or not. Okay, compulsory executable statements we write generally in finally block. So basically, why are we going with exception handling? So if you don't handle those exceptions cases, right, your application abruptly it is going to be terminated. Okay, so to avoid that problem, right, instead of terminating entire application, simply the code which is causing that exception, only we are going to terminate it, right? So using this exception handling mechanism, we will see further nested try and other keywords like throws and user defined exceptions, and how can we categorize exception classes. We'll see some exception class hierarchy and all in the next session. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.